Okay, simplifying radicals. So to simplify radicals, first thing we're going to do is we're going to say what times what is equal to that number. Okay? By radical, I'm talking about the square root. I'm simplifying what's under that square root. So what times what is equal to 36? Well, let's say I completely blank. I have no clue. So I'm going to be like, oh, 36 is an even number, so therefore I can divide it by 2. So I can say 36 divided by 2, that is equal to 18. So I can be like 2 times 18 is equal to 36. All right. Now I have no pairs there. So let's see. Can I break that down even further? So nothing, like 2 doesn't break down any further because then I just have 2 times 1, and like we're not counting as 1 as anything. That's like as far down as it can break down. So let's see, can we break down this 18? What I'm trying to do is I'm trying to find pairs. Again, let's say I completely blank and I'm like, I have no clue. All I can tell is, oh, 18 is an even number, so therefore it's 2 times something. So 18 divided by 2 is 9, so 2 times 9. Yes, there I have a pair because I have a pair of 2's. All right, let's see. Can I get another pair somehow? Let's see. Can that 9 be broken down? What times what equals 9? And I can be like, oh yeah, 3 times 3 is equal to 9. Well, there I have a pair of 3's. So anytime I have a pair, that pair comes out of my square root box. So out of my square root box, I have a 3. And then the other thing I have outside of my square root box is a 2. So 3 times 2, both of those are out of my square root box. 3 times 2 is 6. So 6 is all I have, and all of that stuff, all that whole 6 is outside of the square root box. Nothing stayed inside. All right? So let's try that with this next one, 8. So I break the 8 apart, and again, I'm like, I don't know, well, 8's an even number, so 2 times 4. Okay? No pairs yet. Let's see, can we break this 4 apart to find pairs? Yes, 2 times 2. So I have a pair of 2's right here. But there's a problem. When I look at the branches of this tree, I end in pairs right here, but what about here? This branch did not end in a pair. This branch is still left inside the box, inside the square root. So when I put a box around it, I'm like, that stays inside of the square root. The reason why I'm not even looking at this 4 as a branch, because it already branched out further. That's not the end of a branch. I'm looking at the end of the branches. Okay? So this is now every single thing has either a circle or a box around it, which means I'm done with that. So circles come outside of the square root. So I have a pair of 2's, and when I have a pair, it just reduces to 1 outside of the boxes. So 1, 2 comes out of the box. All right, that pair of 2's, I took care of that. Next, inside the box, I have a 2 left over. So square root of 8 simplifies as 2 square root of 2. That's my answer. Okay? That stays inside the box. Pairs come outside the box. Okay? Let's try this one. 50. Let's see. This time I'm a little bit smarter. I'm not looking for just even numbers and being like 2. So instead I'm just like, oh, I know this one, 5 times 10. All right, 5 times 10. No pairs yet. Can we make pairs? 2 times 5. The 10 can be broken up into 2 times 5. There we have a pair of 5's. So this pair of 5's comes out, okay? My tree ends in a pair of 5's there, but this tree branch right here has nothing, no pairing. So this stays inside the box. So the pair of 5's comes out, so 1 pair of 5's out, and inside the box stays the 2. All right, and you might be like, well, you said the pair of 5's comes out. Why do I only see 1 5 out? Because each pairing, when you pull it out, it only goes down to 1 5. Okay? So there we go. That reduced to that. Number 4. What times what equals 81? Oh, 9 times 9 is equal to 81. Do I need to break this 9 down further? I could break it down further, but I have pairs. My whole point of doing this whole thing is to find pairs and to like have my tree end, like no more branches. So like, yeah, there's like my tree ended in pairs, so I'm done. So that comes out of the box, and so I just have 9 completely out of my square root. I just have a regular 9 answer. Okay? The pair reduces to just that, like 1 9. Okay? This time I already have something outside of my square root. I already have a 17 outside of the square root. Well, it's already out. I'm not going to bother with it right now. I'm just going to remember it later when I'm pulling things out. Okay? So 175, how do I reduce that? Well, let's see. It ends in 5, which means I can divide it by 5. So 175 divided by 5 is equal to 35. So 5 times 35. And then I'm like, oh, I remember 7 times 5 is 35. So 5 times 7 is 35. So here we have a pair of 5s. And then I have to look at this tree branch. Can the 7 be reduced any further? Nope, nothing. Like if I'm just going to get 7 times 1. And I said once you get to something times 1, that's the furthest you can reduce it. So there's nothing times anything other than 7 times 1 that will give you 7. So that stays in the box. So these 5s come out. So I have 5 out of the box. I already started with 17 out of the box. So I have to go ahead and multiply those two. And inside the box, the 7 stays. All right, now I'm not all the way done simplifying because I can go ahead and multiply that 17 times the 5 outside the box, right? So 17 times 5 is equal to 85. So this becomes 85 and outside the box, and then inside the box we still have 7. Okay. All right, 72. Let's see. I think I remember this one. Oh, 8 times 9, right? So 9 times 8 is 72. Okay. So this can be reduced to 3 times 3 because we don't have pairs yet. And this one can be 2 times 4. So we have a pair of 3s over here. No pairs here yet. Let's see if I can reduce this to find pairs. 2 times 2. So I have a pair of 2s. And then this 2, no pair. There's no other 2 that's paired with that. These 2's already are paired together. They're done. So that 2 does not have a pair, so it stays inside the box. So outside of the box, I have a 3, and then I also have a 2 for this pair of 2's, and then inside the box, I have the 2 left over. Now, when I look closely at this thing right here, I see this negative sign outside the box as well. So I need to go ahead and keep that negative sign as well. So now this becomes, let's see, 3 times 2 is 6. So 6 outside the box, we still have the negative sign, and then inside the box is the 2. So that's what we end up with there. And it gets even more complicated. All right. Ooh, we're multiplying things on top of everything. All right, so I'm going to go ahead and just multiply the 2 things that I see outside the box. I'm going to multiply those. And then the 2 things I see inside the box, I'm going to multiply those. All right, so outside the box, I already have 8 times 2, so that becomes 16. And then inside the box, I have 3 times 6. Right? So that's inside the box. So I already know I have 3 and 6. Let's see if I can get a pair. Well, I have a 3 and a 2. There we go. We have a pair of 3's, and the 2 is left. Okay? Why did I use this 3 up here? Because I still had to multiply the 3 and the 6. So it's already a multiple. It's part of that tree. So now I have a pair of 3's. I'm bringing them out. So I have a 16 already out. I took a pair of 3's out, and then inside the box I have a 2. All right, so 16 times 3, that's outside. I have to go ahead and multiply that. I get 48. So 48 square root of 2 is what I get on example number 7. All right, now example number 8. Ooh, gets more complicated. All right, let's see. We could simplify that. All right, so example number 8, there's a couple things we could do. We could just create this as 2 square roots on top of each other, right? Or the other thing we can do, yeah, let's do that, 2 square roots on top of each other. So that means that we have this square root of 169 that we have to simplify. What times what equals 169? Well, we've got 13 times 13. That was easy. We've got a pairing right there. Okay? So that's the top one. Now the bottom one, 225. Well, 225, I see a 5 there, so I know that it's a multiple of 5. So I get 5 and 45. And 45, I can simplify that into 5 times 9. And the 5 times 9, that simplifies into 3 times 3. So I have pairs right here, and I have pairs right here. So I pull that out, I get a 5 out, and I also get a 3 out, which means I have a 15 out. Okay? And then on this side, I have the 13 out. So now outside of the box, I have 13 on the top, and then I have 15 on the bottom. They're both outside the box. I just pulled them apart into 2 different square roots. Okay? So that's one way you could do your square roots if you have a top and if you have something both at the top and at the bottom of your square root. Now, another way to deal with fractions. Okay? Now, it is considered very bad form, okay? When we simplify, I'm going back to this other page. When we simplify our radicals, if we have a square root on the bottom, we are not done. We have to do more with the square root on the bottom, okay? So here's the problem. We have a square root on the bottom. And 2 does not simplify anymore, right? You can't break 2 apart even further. What times what equals 2? Well, we just have 2 times 1. It's already as far broken apart as we can get it. So on this particular one, to get the square root of 2 out of the bottom, what we're going to do is we're going to multiply both the top and the bottom by square root of 2 divided by square root of 2. Okay? Because this is the same thing as 1, just in this square root form, right? Because square root of 2 divided by itself is 1. 3 divided by 3 is 1. Square root of 2 divided by square root of 2 is 1. Something divided by itself is always 1. Okay? So now when I multiply the top and the bottom by square root of 2, the top, when I multiply it by square root of 2, I get 3 times square root of 2. The bottom, when I multiply it by square root of 2, well, square root of 2 times square root of 2 is equal to just 2. Now, if you don't believe me, look into your calculator. If I do, if I do square root of 2 times square root of 2, that is equal to just 2, right? So a square root times itself is always equal to this thing outside the box. It's always just a regular 2, right? So that's what you end up with. That is the simplified version of 3 divided by square root of 2. Now, an easier way to remember how to do this, instead of just being like, oh, multiply by 1, which is the square root divided by itself, you can just be like, oh, what I end up with is this square root at the top divided by the number outside of the box. Like, take that number and move it outside of the box. So if I were to do the same exact thing there, I would take the top, multiply it by the bottom, and then take this bottom number out of the box right here. That's what you end up with. Well, when I see that that's what I end up with there, I can actually reduce that even further, because we have outside of the box, what do we have? We have both a 6 and a 3 outside of the box. I can go ahead and take my 6 and divide that 3 into it. All right, and then outside of the box, 6 divided by 3, I get 2. So 2 square root of 3 is what I end up with. Okay, because not because of this thing right here, but because these two things right here can be divided, right? I left the square root completely alone. That's still there. Okay, so now last two problems. I said it's bad form to have a square root in the denominator. And how do I get rid of it? I just move the square root up, and then I divide by whatever was on, like, in the box down here. So 5, move the square root of 2 up, divide by 2, take it out of the box. And we're done. 5 does not divide into 2. 2 does not divide into 5 evenly. Okay, so that's that. Okay, this time, same thing as before. I'm going to move this up here. So I'm going to go ahead and say 6 square root of 2 times square root of 3 divided by a regular 3. Okay? Well, square root of 2 times square root of 3, I get square root of 6. So, and then these two right here, the two outside of the box, I can go ahead and divide those evenly. So 6 divided by 3 is 2, right? So that got divided evenly. We're done with that. Now inside the box, I got 2 and 3. So I'm going to go ahead and multiply the 2 and the 3 both inside the box. I just moved them inside one box, right? And I get 2 square root of 6. Okay. And that's that.